Alright, so in this problem, I have 0.2 to the power of x is equal to 2. So for this problem, I want to find the value of x. So for my solution, first start with 0.2 to the power of x is equal to 2. Now I'm going to take the log on both sides. So I have log 0.2 to the power of x is equal to log 2. And if I have something in the form log a to the power of b, I can actually move this exponent b here to the front. So this can equal b times log a. So in this case, I have log 0.2 to the power of x, and I can move x to the front. So now I have x times log 0.2 is equal to log 2. Now if I divide both sides by log 0.2, these two cancel out, and I get x is equal to log 2 over log 0.2. Now, if you notice here, log 0.2, well, that's the same thing as log of 2 over 10. And if I have something in the form log a over b, this is simply equal to log a minus log b. So in this case, a is 2 and b is 10. So I can rewrite this as x is equal to log 2 over log 2 minus log 10. Now, log 10, as we all know, is simply 1. So I have x is equal to log 2 over log 2 minus 1. Now, log 2, this is equal to 0.3010. So I have 0.3010 over 0.3010 minus 1. And now this is equal to 0.3010 over 0.6990. And finally, if I divide these two, I get that x is equal to, this is actually negative 0.6990. X is equal to negative 0.43. Alright, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So I want to find the value of x here. So for my solution, first start with x to the power of x to the power of 6 is equal to 144. And now I'm going to take the power of 6 on both sides. So now I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And a to the power of m times n, well, this is the same thing as a to the power of n times n, because when I'm multiplying two numbers, I can switch the places of them to. It's still the same value. So if a to the power of m to the power of n is equal to a to the power of m times n, and a to the power of m times n is equal to a to the power of n times m, this means that this is the same thing as a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. So we can think of x to the power of 6 here as m and 6 as n. So if I switch the places of these two, I get x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. So now I'm going to let x to the power of 6 equal to the variable y. So now I have y to the power of y is equal to 144 to the power of 6. And 144, this is the same thing as 12 squared. So now I have y to the power of y is equal to 12 squared to the power of 6. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, as I already said before. So 12 to the power of 2 to the power of 6, that's going to equal 12 to the power of 2 times 6, which is 12 to the power of 12. And if I have something from a to the power of a is equal to b to the power of v, this means that a is equal to b. So in this case, y is equal to 12. So now remember how we let x to the power of 6 equal y. So this means that x to the power of 6 is equal to 12. So if I take the 6th root on both sides, 6th root of x to the power of 6 is x. So I get x is equal to 6th root of 12. Alright, so in this problem, I have 3 to the power of x minus 2 to the power of x is equal to 65. So to start, I'm going to take the power of 2 over 2 on both sides. So now I have 3 to the power of x to the power of 2 over 2 minus 2 to the power of x to the power of 2 over 2 is equal to 65. And 2 over 2, that's the same thing as 1, and anything to the power of 1 is itself. So we are still going by the rules of mathematics here. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of n. So in this case, I can switch the places of these two. Sorry, I can actually switch I can actually rewrite this as 3 to the power of x over 2 to the power of 2. So now I have 3 to the power of x over 2 to the power of 2 minus 2 to the power of x over 2 to the power of 2 is equal to 65. Now, I'm going to let 3 to the power of x over 2 equal to the variable a, and 2 to the power of x over 2 equal to the variable b. So now I have a squared minus b squared is equal to 65. So a squared minus b squared, that's the same thing as a plus b times a minus b, which is equal to 65. And 65 I can rewrite as 13 times 5. So in this case, a plus b would obviously be greater than a minus b. So we can think of a plus b as 13 because 13 is greater than 5, and a minus b as 5 because we have something times something is equal to something times something. So an a minus b is less than a plus b, so a minus b would be 5 because 5 is also less than 13, and a plus b is greater than a minus b, so a plus b would be 13. So now this is a simple system of equations. These two cancel out, so I get 2a is equal to 18, meaning a is equal to 9. And if a is equal to 9, then b is equal to 4. So now, going back here, I have 3 to the power of x over 2 is equal to 9, and 2 to the power of x over 2 is equal to 4. So 3 to the power of 2 is obviously equal to 9, so I have x over 2 is equal to 2, meaning x is equal to 4. And I have, again, let's try this out. If we plug in 4 here, we get 2 to the power of 2 equals 4, and 4 equals 4, so that works out. So 4 is my solution. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have x to the power of x is equal to x to the power of 2x squared. Now, what I'm first going to do is I'm going to take the natural log on both sides. So now we have ln of x to the power of x, and this is equal to ln of x to the power of 2x squared. Now, an important property of logarithms is that if we have something in the form ln to the power of ln of a to the power of b, we can actually move this exponent to the front. So this would be b times ln a. So this is exactly what I'm going to do to both of these. I'm going to move the exponent, which in this case is x, and 2x squared to the front of the logarithm. So now we have x times ln x is equal to 2x squared times ln x. Now if I factor out ln of x from this, I get ln of x times x minus 2x squared. And this is equal to 0. And now this gives me two equations. ln of x equals 0, as well as x minus 2x squared is equal to 0. For ln of x equals 0, this means that x is equal to 1. So this is one solution to this equation. And for x minus 2x squared equals 0, this is equal to x times 1 minus 2x is equal to 0. And this means that x is equal to 1 over 2, as well as x is equal to 0. However, x equals 1/2 is a solution. However, x equals 0 is not a solution, because if you plug this in, you get 0 to the power of 0, which that is not a defined value. So x equals 0 is not a solution.